Welcome to solverfy, the place where learning becomes simple. If you're struggling with homework, assignment, or doubt in subjects, don't worry, you are in the right place.
Part A is asking for the tension connecting blocks A and B. And like most of these problems, we're going to start off by drawing a force diagram. First, I'm going to draw the force diagram for block A. It has a tension force pulling left. It has a normal force, which I'm going to call NA, pushing up. It has mass pulling down, which I'm going to call mg. Since the mass of block A is unknown, we just call it m. And then it's got a friction force, which I'm going to call friction force on A, pulling to the right. Now, sum of the forces in the y direction equals 0. 0 because there's no acceleration in the y direction. And I should set up my coordinate system. It'll be that, where this is positive x and this is positive y. So the block's not going to jump up in the y direction, so we can set equal to 0, which implies that the normal force on A is equal to mg. Now, the sum of the forces in the x direction is not equal to 0. It's equal to the mass times the acceleration in the x direction. This implies that tension minus force of friction on block A is equal to 1.5 times m. And I'm going to denote this equation by star. It'll be useful as we do part B. Now I'm going to draw the force diagram for block B. This one will have a vertical component in B. It has a force over here of 40 newtons, and it's at an angle of 53.1 degrees. We have gravity pulling it down. We do know the mass, it's 5, so the gravity is 5g. We have a tension force here, same tension as the previous block, and then we have another force, and it's the force of friction on B. Now, sum of the forces in the y direction is still equal to 0, and this implies that 40 times sine of 53.1, which is the vertical component of the applied force, plus the normal force, minus the component of gravity, is equal to 0, which tells us that the normal force is 17 newtons whenever you plug in g and do this out. And then this immediately implies that the friction force on B is normal force times coefficient of kinetic friction, and that's given in the problem. So we can easily solve this to get 5.1 newtons. Now, sum of the forces in the x direction is again not equal to 0. It's equal to mass times acceleration in the x. And we know the mass and we know the acceleration, so this is equal to 5 times 1.5. Plugging in for our forces, we get 40 times cosine of 53.1 minus t minus force of friction on B is equal to 5 times 1.5. We can solve this for tension and get that tension is equal to 11.42 newtons. Here I had to substitute in what the force of friction on B was, which we found here. And so that's the answer to part A. For part B, we want to figure out what the mass of block A is. And to do that, we're going to go back to the equation I starred earlier, this one. We just figured out what the tension was. And so now we just plug in what the friction force on A was. Friction force on A is equal to mu, K, which is given in the problem, times NA. And we know what NA is by this. We know it's mg. So we know ultimately from this equation that tension minus mu k mg is equal to 1.5 m. And we're trying to solve for m. And in part A, we solved for tension. And so the only thing we don't know is m. And so we can solve for it. When we do that, we get that m is equal to 2.57 kilograms. And that completes the problem.